Okay, this is 13.2, and what we're going to look at is 22, 26, and 30. Okay, so let's look at 22 first. 22 says this: a wheelchair ramp is to be built at the town library. So there's the library. Here's the start of the ramp. And I think I'm going to zoom this in just a little bit. Okay, that's better. Get that straight. A little seasickness there for y'all. Okay, a wheelchair is to be built at the town library if the entrance to the library is 18 inches above the ground. So there it is, 18 inches above the ground. And the slope of the ramp is 1/15. How far out from the building will the ramp start? So what we need to do is figure out if this is, okay, my picture's not great. But, here's the library here. And it's 18 inches up from the ground, and so I need this ramp. So I need to find this distance here, okay? And I know that this is 18. I don't know what this is. I'm going to give a variable named x. I know that the slope of the ramp is the rise over the run. It's 1/15. And so that is equal to, starting here, the rise, that's this distance right here, over the run, this distance right here. This is 18, since I have a rectangle there. This is x. Rise 18 over run x. So 1/15 equals 18 over x. All right? So product of the means equals the product of the extremes. 15 times 18 equals x times 1. So x is equal to 15 times 18, which is 270 inches. Now, that's inches. We need to convert that to feet. So the way I'm going to convert that to feet is I'm just dividing by 12. So 270 divided by 12, that's 22 with 6 remaining. So 22 and 6/12, or 22.5 feet. So this is 22.5 feet away from this start of the library. Okay, so there's that one. Okay, 26. Let's look at 26 now. 26, I think, is a great problem. I love this problem. Okay, zoom that back a little bit. Okay, 26, you have this picture here, and you need to find out, for part A, the slopes of OD and NF. So on this one, I'm just, I did this on graph paper so you can see. It's easy to count here. The OD, the slope, is the rise, 1, 2 units over the run, 1, 2, 3. So it's 2/3. All right, the slope of OD. The slope of NF, you can see the rise up 2 and run 3. So the slope of NF is 2/3. Now, we want to know, for part B, why the two triangles are congruent. Well, if you'll notice, this OC is congruent to NE. These are both right angles here. Angle C and angle E are both right angles. And DC is congruent to FE. So by side angle side, we have that the two triangles are congruent. Now, the thing that's kind of nice is you could do side, side, side. You could use the distance formula and find this length here. You could find this length here. Side, 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 side angle side. That's good. All right. Once I showed that the two triangles are congruent, why is this angle DOC congruent to FNE? Well, because if the triangles are congruent, then their corresponding parts are congruent. So that's the answer to C. Now we want to know, why is line OD, it's this line, and remember, lines keep going on and on and on forever. So take a look at this here. I want to know why OD, I'm going to turn this around just slightly so you can maybe see this a little bit better. Why is OD congruent to NF? Now take a look at these lines and think of this guy like the transversal. I'm looking at this angle here and this angle here. When these OD and NF are your lines and this ON is the transversal, you can see that these guys are corresponding angles. So the reason those two angles, DOC, is congruent to FNE, because sorry, I'm on part D. OD and NF are congruent. Oh, I'm really boogering this up. OD and NF are parallel because we just showed that that angles DOC and FNE are corresponding angles that happen to be congruent. Okay? Corresponding angles, so the lines are parallel. You can tell I've been off for Easter vacation because I'm just not that fluid with my speech these days. Okay, then the last question is, for part E, what do you think is true about the slopes of parallel lines? What we notice is in part A we said that the slope of OD was 2/3 and the slope of line NF, or segment NF, was 2/3, and the slopes of parallel lines are equal. Okay, so that actually is a really good kind of segue into 13.3. Okay, the last problem for 13.2 is this one. What you have to show is that the tangent of angle A, here's angle A, 0, 0, B is 5, 0, C is 5, 4. We want to show that the tangent of A is equal to the slope of AC. All right, so we know that the tangent of A is equal to the opposite over adjacent. Remember SOHCAHTOA? The opposite side length is the length of CB. And you can see, since this is a vertical line, you can just count 1, 2, 3, 4. So the length of CB is 4 units long, and the length of AB, which is the adjacent side, 1, 2, 3, 4, 5. So that's 5 units long. So the tangent of A is equal to 4/5, which is equal to 0.8, just saying. Now, the slope of AC is the rise over the run. The rise is this length right here, and the run is this length right here. So this rise is 4. It's the same as this opposite side length, and the run here is the same length as the adjacent side length. So 4, that's the rise, and the run 5. Okay, and so we get 4/5. I could also have just stuck in the values into the formula, delta y over delta x, 4 minus 0 over 5 minus 0. So that's the slope, 4/5. And what I notice here is that the tangent of angle A, 0.8, equals the slope of AC, 0.8. So they're the same. Then they find out, the next question is, well, what is that angle? Well, the angle is A. Tangent of A is equal to 4/5. We know that it's 0.8. From page 311, we can see that the angle 39 degrees has a tangent that's 0.8098, which is the closest I can get on that table. That doesn't go that precise with the answer. But if I want to use a calculator, I can use, since I'm trying to find the angle, I use the inverse tangent. So I put in, tell me the angle, the inverse tangent, tell me the angle whose tangent is point A. That's the measure of angle A. And so the calculator returns a value of 38.66. So that is it for that.